Hi folks, I wanted to do one or two of these examples because I thought you might struggle with these. Let me take you through these. These are very, very tricky, so don't stress if you couldn't get them the first time. Now, the problem with this circuit here, this is question 7C from your latest tutorial, is that when we look at it, we can see it looks like there's something in series, but then it also looks like there's something in parallel and then in series as well. So how do we deal with this? How do we know which part do we add first? Do we add the resistors in series first of all, or do we add the bits in parallel, or then what do we do? So let me give you the top tip, which um, makes this a lot more straightforward because it is very, very tricky to try and figure this out. So imagine you are the current coming along. So you're starting at X and you go through the 10 ohm resistance and you get to this point in the circuit here where the dot is. Now question, what does the current do when it gets to this point here? It's got to split up. So it's got to go down here and then it's got to go down here. So it tells us two things. Number one is that these are actually in parallel to each other, these two branches. And secondly, it means we've got to add what's the parallel bit first together before we can do anything else. So that is the trick, is think about what the current's doing. Is it going through a straight line? Is it going through two different branches? If it is, that means it's a parallel circuit. So essentially what we need to do is work out what's happening here first of all. So I'm going to focus in on this bit here, and straight away we can tell, again, think about what the current's doing. If it's going from this point, it's going through resistor 4 ohms and 1 ohms, and in this branch it's going through 20 ohms and 5 ohms, so that means these must be in series with each other. So our circuit becomes the following. So this is our 10 ohm one, so I'm just going to miss out the units because it's a bit of a pain for me to draw it. We know that that's 4 plus 1, so that's 5, so we can replace it with a single 5 ohm resistor. Okay, so that's a 10 there. And then the second branch, we know we've got a 20 and a 5. So that means we can replace it with a 25 ohm resistor. And then the current will go further on and then join up again, and then it goes through the 10 ohm resistor. Okay, so this is the first step of simplifying our circuits. And if we look at this again, we can see that we again have a parallel circuit here. So we have this 25 in parallel with 5. So if we just add those together, just going to do it on my calculator. Okay, we get 6 over 25, which is not a nice number. So that means my circuit then becomes this. Okay, the 10 ohms still there, the two 10 ohms are still there, but we can then replace it with a single resistor, which is worth 25 over 6. So that's 10, that's 10, and then this is 25 over 6. Okay, and then from there, I think you can all add that up into a single resistor. Okay, so hopefully you can manage to see the logic there. The trick, as I said, is to think about what the current's doing as it reaches a point in a circuit. Does it keep going through a single path? Does it branch off? If it branch off, then it's a parallel bit, then that means you've got to add it in parallel first. But then obviously within the parallel bit, you can see there's two series bit. So you have to do the series bit in parallel, and then you do the parallel bit after that. So that's what I've shown with my different circuits there. So a wee bit more work, but if you follow that rule about thinking about what the current does, you'll be on the right track. Hey folks, so this one here is a little bit more complicated now because we've got a combination of series and parallel resistors. We also have this very weird setup where we've got three cells that are connected together in the right way. Okay, and they give you a total of 6 volts. And then we've got a single cell which is actually connected the wrong way round. How do I know the wrong way round? Well, if you imagine the current going round, you can see it's going from a negative to a negative, which is not allowed. Okay, now what's the effect of this? Well, the effect of this is that this cell here will actually cancel out some of this cell's here's kind of effort, if you like. So what's the overall effect? Well, think about how many cells we've got here. We've got 3 cells. So each cell is actually providing 2 volts worth of potential difference. So that means this must also be giving me 2 volts, but it's going in the opposite direction. So that means it's going to cancel 2 of the voltages here, and so the voltage supply must be 4 volts. Okay, so let's write that down straight away so we can see that. Okay, another way to think about it is if you've got 3 people pushing in one way and you've got another person pushing the opposite way, that person pushing the opposite way is going to cancel at least one of the person who's pushing against him. So that's the idea that we've got there. Okay, so the first thing we're going to try and work out is part A. What is the reading on the ammeter? Okay, so before I do that, let's just clear the circuit a wee bit to make it a little easier for you to see what's going to happen. Now, if we assume that we've got the answer supply voltage is 4 volts, we're going to change that as well just so that we don't confuse ourselves. So there, this is going to be 4. Okay, and if we assume that's 4 volts, we can just ignore that cell and pretend it's a lead that's going through here. Now, the question is, how do we work out the current when we've got this kind of combination of parallel and series? And how do you know which bit's which and which one do we add first? Well, it's the same as last time. We think about what the current's doing. The current starts from here because it's a negative terminal, gets to this junction here, and then what does it have to do? It's got to split up. It's got to go down here and here. So that tells you straight away that these two are parallel and you've got to add them together because it's the first thing that happens. When the current gets to here again, it combines again and then you've got a series circuit. So these two resistors are parallel to each other, but they're in series to the 2 ohms once you've worked out the parallel bit. So before we get too carried away, let's work out the 2 resistors in parallel. Okay, so we've got our original 2 ohm resistor here. Nothing happens to that. And then what are we going to replace those 2 5 ohm and 20 ohm resistors with? Well, if you work that out in your calculator, you should get the answer as 4 ohms. Okay, so remember you're adding 5 and 20 in parallel, so you get 4 ohms. Okay, and then from here it's pretty straightforward because these are both in series, so that means we can replace it with a single resistor of the same value as the 2 of them added together, which is 6 ohms. So here we know that the final simplest circuit has 6 ohms in it and 4 volts. And that allows us to work out the current because current is I is equal to V over R, remember Ohm's law, so it is equal to 4 over 6. Now we can multiply this, divide this out, or we can just leave it as a fraction. I'm just going to leave it as a fraction just now because it's a much nicer number. Okay, so it's 2/3 amps. And that's the answer for part A. Now we can say that because if you think about it, the resistor is actually in the series part of the circuit, so it must just be the total voltage, which is the same as the total current, sorry, which is the same as here. So it's got to be 2/3 of an amp. Okay, folks. Now let's have a look at part B on the next slide. So here, let's just update our circuit again. So we know that the supply voltage is 4 volts. We know that the current reading is 2/3 of an amp. Okay, we're always using that KFC technique, folks. Know it, find it, calculate it. So it says calculate the current in the 20 ohm resistor. Now this is a bit of a tricky one because it's in parallel and we know that currents will split up in a parallel circuit. So how do we work out how it splits up? Because you can see there's 5 ohms here and there's 20 ohms. It's not straightforward. Well, hopefully one of the things you realise is that in terms of a ratio, a common factor is 5 for both these numbers. So that means this simplifies to 1. and this simplifies to 4, okay? Because 5 times 1 gives you 5, 5 times 4 gives you 20. Now, the second thing you need to remember is that current will always go through the path of least resistance. So which one of these will have the bigger current? And the answer is this one here. Because it's only got a 5 ohm resistance, you'd expect more current to go through here. Okay, so I'm going to work out the answer very quickly, and then I'm going to tell you what how to actually get the answer. So for the 5 ohm resistor, what do we expect the current to be? And for the 20 ohm resistor, what do we expect the current to be? So let me work it out on my calculator first, and then I'm going to show you how it's done basically. Okay, so okay, and then right, so let's work this out. So for the 20 ohm resistor, it's going to be 8 over 15ths of an amp. And the reason why I've got it in fractions is just because I left it as a fraction. Now, knowing that, you should be able to tell me that the current going through, sorry, I've got this wrong way around. This is actually going through the 5 ohm resistor, because remember, it's going to have more current going through it. And in the 20 ohm, you should be able to tell me it's got 2/15ths of an amp going through it. Okay, how do I know that? Well, because in parallel the current splits up. So if I add 2/15ths to the 8/15ths, then I should get 10/15ths, which is the same as 2/3. So we know we're being consistent. Don't get caught out like I did. Remember, the smaller the resistance, the bigger the current going through it. So that's why it's got the 8/15th over it rather than the 20 ohms. Now, how did I work that out? Well, one way to work it out is the following. If you recognise that there's a ratio of 1 to 4, okay, so there's a ratio of 1 to 4, well, that means the total must have 5 bits to it. So the total must equal to 5 bits. Okay, so what's 1 bit worth then? Well, all we do is we just do 2/3 divided by 5. Okay, and that gives us an answer of, let me just work it out on the calculator. So 2/3 divided by 5 gives me an answer of 2 and a 15th. Okay, so that tells me there's 2 over 15 amps going through the 20 ohms, because that's got 1 bit to it. The 5 ohm has 4 times the amount, so we just do 4 times 2/5. And that gives us, you can probably work it out in your head now, the 8 over 15th amps. So that's how you work out how this ratio splits up. Work out what the total number is, because you've got 1 to 4, so it's simply 5. You divide your current by that 5, and that will tell you what 1 bit is worth. Go back to your ratio and figure out how many, what the actual answer is. Okay, so that's how you do part B there, and the answer is that there is 2/15ths of an amp going through the 20 ohm resistor. Okay, now to the final part of this question, which says calculate the voltage across the 2 ohm resistor. Okay, and this is actually the easiest bit because we already know what the current is. It's 2/3 of an amp, because remember this bit is in series, so the current is the same everywhere. We know what the resistance is. It's 2 ohms, so we just use Ohm's law. V is equal to I times R. Okay, and then all we do is just 2/3 times 2, which gives us 4/3 of a voltage. Okay, 4/3 of a voltage, and that gives us the answer there. Now, what's really nice about electrical circuits, is one of the reasons why I quite like doing them, is you can actually check your answers, because if we know this 4/3 of a volt here, We know what this voltage supply is. It's actually 4 volts. So we could work out that 4 minus 4 thirds. Right, let me do that again on my calculator. 4 minus 4 thirds gives me 2 and 2 thirds. Now, because the 5 ohm and the 20 ohm are in parallel to each other, but they are in series to the 2 ohms, that means these two must have 2 and 2 thirds of a voltage going across each of them. We can check that because previously we knew that the current going through the 20 ohm resistor was 2/15, wasn't it? So we can use Ohm's law again, V to IR, to work out the voltage across there. So in this case, it would be 2 over 15 times 20, which gives me 2 and 2 thirds. So that tells me my answer here is correct because it's consistent with my rules of combining circuits and Ohm's law. Okay, and this is why physics is really nice, folks. So hopefully that's given you a wee helping hand with those two questions. Obviously, if you're still stuck, feel free to speak to me and I'll try and help you as best I can, folks.